Hello everyone. Today we are going to write a program for magic square. In the video you saw Amit was trying to solve magic square of size 3 cross 3 and he was taking a lot of time because he was trying to solve the magic square using brute force way, which is possible for 3 cross 3 square matrix but not possible for, let's say, 5 cross 5 and 7 cross 7 and even 9 cross 9. So we'll see that how we can write a program so that we can solve any kind of magic square in an efficient way or in an easy way. So we know that in 3 cross 3 magic square the sum is actually 15. So let me revise the rules of magic square. What you have to do, you have to create let's say I give you a number n. You have to create a square of size n cross n such that sum of each row is m. M is my magic number. Sum of each row should be m, sum of each column should be m, and even the diagonals, sum of the diagonals should be m. If it happens, then you got the magic square. So the question is it possible to create a magic square for any number n? Let's say if I give n is equal to 3, so my matrix should become 3 cross 3. It should have exactly 9 elements, and sum of each row should be some m. M could be anything, but it should be unique. I mean, sum of each row should be m, each column should be m, and the diagonal should be m. So we'll see how we can do with how we can create a program in Python so that it can solve any kind of magic square. So we'll tell you that the size of n can take any number, but it should be odd. It should not be even, and we'll write a program for that. Before that, I will encourage you guys to look at the Wikipedia page of magic square. It has all the entries regarding magic square and even history of magic square and even the algorithm to solve the magic square. I'm going to use this algorithm only to write a program in Python. So before I go writing a program, let me tell you some facts. Okay, so you can see here there is a magic square of size 3 and magic square of size 5. We know that what is the magic square of size 3, that is 276, 951, 438. If you sum it, then each row is becoming 15. 6 plus 7 plus 2 is 15, 9 plus 5 plus 1 is 15, and even diagonal sum, both diagonal is, the sum is 15. Here is another magic square of size 5. You can find the sum of each row and each column. It will be 65. So before we go on writing a program, let me tell you some fact. Fact number 1 is that for any magic square, for any n cross n magic square, the magic number is always this, which is n into n square plus 1 divided by 2. So let's say for 3 cross 3 magic square, n becomes 3. So 3 square of 3 is 9 plus 1 is 10 divided by 2, 5 into 3 is 15. So magic number becomes 15. And for magic square of size 5, that is n is 5, 5 is 25, 26, 13, and it is 55. Oh, 65, sorry. Yeah. So we are going to use this fact. Another thing is that whenever you see a magic square, you will find a pattern here. The pattern is that see the position of 1. The position of 1 is always in the middle row and the last column. Okay, whatever magic square you use, you can even see the magic square of size 7, and in that also you will find that it is in the middle row. The 1 is always in the middle row and the last column. So we are going to, based on that, we are going to use this algorithm. We are going to define the algorithm and we are going to use this algorithm to write our program. So let's see this. So step number 1 is, first we have to determine the location of 1. So we'll fix 1. After that we'll go on to other numbers and we'll fix their positions, and by this we'll try fitting our numbers and we'll create our magic square. So first is, we know the as I told you, in any magic square 1 is located at position n by 2 comma n minus 1 for any general n cross n matrix, square matrix. N by 2 will give me the position of row. Okay, so for example for 3 n by 2 becomes 1. I'm taking the integer number, so 0 1. First row is 0, second row is 1, third row is 2. So 1 is this position, and n minus 1 is the column position, which is 2, so second column. So my position of 1 is this, which is first row and second column. For magic square of size 5, it becomes 5 by 2, which is 2, which is the second row, 0 first, 0 1 2 second row, and the last column, that is n minus 1, which is fourth column. We are assuming that we'll always assume here that the matrix starts with 0 cross 0 or 0 comma 0, sorry. Okay, now after determining the position of 1, we'll see where 2 lies. Now see here, the position of 2 is also, there is a pattern for 2 also. You can see 2 is here, when 1 is here, again the 2 is here. So let's say the position of I take this, the position of 1, which is n by 2 comma n minus 1, as p comma q. Let's say the position of 1 is p comma q, this is p comma q, this is p, this is q. Then next number, which is 2, is located at p minus 1 comma q plus 1. See this, 1 is at 2 comma 4. Now if you take p minus 1, which is 2 minus 1 is 1, and q plus 1, q is here 4 plus 1 becomes 5. Now 5 is not there. What does this mean? So let me tell you the second line. Anytime if the calculated row position become minus 1, then make it n minus 1, and if column position becomes n, then make it 0. Here column position is becoming n, which is 5 is n, so you have to make it 0, so it will come 0. So now see, my location is p minus 1, which was 1, and q plus 1, which was 0. So 1 0, sorry. So new location is 1 0, so I will put my 2 here. So like this I will do for calculate for other number also. Now after this I will calculate for 3, again using the same thing. Now the third step is, not the step, I mean third fact is, if the calculated position already contains a number, suppose you calculated a position and it already contains a number, then decrement the column position by 2 and increment the row position by 1. We'll see this, how it happens. Now the last fact is, if any time row position become minus 1 and column position becomes n, switches to 0 comma n minus 2. So I'm going to use these 3 conditions or facts or algorithm. Say it is not algorithm because I didn't define the steps. These are not steps, these are facts only. So I'm going to use these facts as a condition to write my program, and based on this I will create my magic square. So in next video you will see how we can use these steps to create our